That again is how things work when all the packets, all the data is going back and forth. But here in this picture, the client side has sent more bytes in its window that have not yet been received by the server. So let's suppose the receiver received the third byte and the seventh and eighth byte, but not the ones in between. At this point, if those packets got lost, then the receiver is just kind of waiting around until the client side times out. The sender on the client side times out and decides to resend them. But if it's getting these packets with gaps in between, then there's a good chance that something has in fact gone wrong, and maybe it would be a good idea to the receiver to tell the sender those bytes got lost, maybe send back earlier rather than later. And the way TCP does this is whenever a receiver gets an out-of-order byte sequence, it can't acknowledge it because it has to do cumulative acknowledgements, but what it can do is re-acknowledge the bytes that it has so far. And the rule is, in TCP, when the receiver has this third re-ACK, then the sender will interpret that as a sign that lots of things are missing, and so it'll start again, trying to send the bytes that are in its window. So the third ACK that's acting as an out-of-order ACK will provoke the sender from timing out faster rather than slower. At the same time, if a packet is received in order, as expected, the receiver could ACK that right away, but it's a good idea to wait a few milliseconds and see if some more data comes in so that this receiver could ACK even more at the same time and cut down on acknowledgement packets. Which might have data in them, but maybe it doesn't have data and it would otherwise just been sending acknowledgement packets. So there is a little delay here in TCP before the receiver is going to send back an ACK. That delay is configurable. It can go up to something on the order of half a second. And that again just makes the overall protocol more efficient, makes the cumulative ACKs more likely to report more accumulation. Now what if we're in the state where 3 repeated ACKs have been sent back, but even those ACKs are getting lost in the middle of the network somehow? How soon should the sender time out? The answer is that the sender starts with a small timeout, but every time that doesn't work, then it waits twice as long as it waited before. And this is called exponential backoff because the client will say wait 10 milliseconds, and then it'll wait 20 milliseconds, and then 40, and then 80, and then 160, and pretty soon it's starting to wait quite a long time. So it's exponential because that time can grow very quickly. And this is a good policy because it helps the communication adapt to whatever the real throughput and availability is of the network in between the client and the server. It's also something that you can notice as a programmer. So you've made a connection and the data has gotten stuck because something went wrong, but now you've got it all fixed and it still hasn't recovered yet. That's because you probably have to wait about as long as the problem was in place for things to get back to normal.